Let's open the Taxon interface, which runs in a web browser and pulls from a database on the server. When we click on the Prusa 3D printer machine, we see the printer loaded into the scene and the machine plan viewer. The machine plan has metrics, which are properties innate to the machine as a whole, and blocks, which describe the machine's composition. We'll run through a quick example illustrating how blocks work. Consider a machine consisting of just part of the 3D printer. Here we have a block representing the vertical double lead screw frame of the printer. In the machine plan viewer, we can see the block's dimensions and also that it has a connection to a child block called the crossbar assembly. We are actuating the block using an action in the workflow editor. When a block actuates, all of its descendants move on the block's actuation axis. Moving back to the full printer, this principle of actuation compounds to be able to move the extruder, shown in red, to any point within the work envelope. In addition to machine plans and workflows, we also have rules of thumb, which are modular, user-defined checks that we'd like to enforce about machine usage. One type of rule of thumb is called filtering rule of thumb, which filters the list of machine plans according to a desired condition. The rule of thumb, called work envelope is larger than blank, takes a value and returns only machines with work envelopes larger than the given width, height, and length. To showcase the second kind of rule of thumb, called action rules of thumb, we'll run through two demonstration machines and workflows. You can read all about all the demonstrations in the paper. First, we consider the Xprint modular liquid printer proposed by Wang et al. At CHI 2016. We check the rule of thumb, dry liquid before next layer to enforce it. We load a workflow from the server that deposits 2 layers of natto cell culture, which curls when exposed to water. We step through each action, first activating the ventilator tool, which allows us to call .fan_on and .fan_off. After depositing the first layer, we turn the fan on and move back to the origin to dry the layer, and then deposit the second layer. If we delete the fan-on action and try the process again, we'll get an error saying that we haven't dried the first layer yet with the fan. Another example is using a pick-and-place machine to pick up different surface mount devices, or SMDs, of different sizes and place them precisely on a printed circuit board, or PCB. Here we have 3 different envelope regions on the upper right for storing each size, and 3 different sizes of needle for picking each kind up on the left. It is crucial that we use the right needle to pick up the right size of SMD. Normally CAD software will include some kind of check for this, but we want to enforce this no matter what software a maker uses. If we move the currently equipped 0402 size needle inside the stock region for the 0603 SMDs, our rule of thumb will throw an error because the tool is not the right size. Instead, we load the correct workflow, where we park the 0402 needle first, then pick up the 0603 needle and equip it, and only then do we move into the 0603 region.